Hard chromium electroplating of metallic surfaces has been a common practice across many industries since the 1930s. Chrome plating is hard, chemically inert, possesses low friction, retains lubricants well, and is highly resistant to wear and corrosion. The Department of Defense uses hard chromium plating extensively during maintenance of aircraft, ships, and weapons systems. The chrome plating protects delicate components from harsh environments.
In its simplest form, electroplating is a process that makes use of a direct current power supply, much like a battery. There's a negative terminal and a positive terminal. An anode is connected to the positive terminal, and the part that's to be plated is connected to the negative terminal. When these are immersed into an electrolyte, which is typically an acid that contains a high concentration of metal ions. The metal ions are electrically driven through that electrolyte toward the cathode, and there they are reduced into elemental form, and they form a thin coating of metal on the part.
Chrome is only plated onto necessary portions of steel engine parts. To prevent unwanted deposition into other areas, these surfaces are typically masked with wax or plastic, using a labor-intensive manual process. Personnel assigned to masking and unmasking must be experienced, typically the best platers in the shop. Because chromium plating doesn't always adhere evenly to all surfaces, parts must be overplated in order to achieve a minimum thickness for the entire surface. Excess is then machined off to specified dimensions. This machining process is wasteful and time-consuming. Thus, the current process for hard chrome plating involves hours of prep, long plating times, and significant cleanup and machining. Plating times for parts at DoD facilities typically run from 1 to 7 days, so multiple tanks are needed to meet DoD production requirements. Plating also requires elaborate racking and fixturing, forcing employees to lean over the tanks, with direct exposure to toxic and corrosive chromic acid fumes.
In traditional chromium plating, the plating bath used is a strongly acidic bath with a highly oxidized form of chromium called hexavalent chromium. It's a health hazard. Hexavalent chromium is carcinogenic and is strongly regulated. Ordinarily, when parts are loaded into a plating tank, the operator has to arrange the part to be plated, has to put in other electrodes, anodes around the part, has to connect the cables going to each of those parts, and in doing so has to lean over the tank, make adjustments, tighten C-clamps, and so on.
While some improvements have been introduced over the past 2 decades, slow plating and very high reject rates continue to be a serious problem. DoD, in partnership with the National Center for Manufacturing Sciences, has been investigating alternatives to the process. The most promising approach is no-mask plating, a new technique developed by NCMS member company Advanced Tooling Corporation. NCMS and ATC partnered with Corpus Christi Army Depot and the Naval Air Systems Command Depot at North Island to apply this technology to the production of key aircraft replacement parts under the Commercial Technologies for Maintenance Activities program. The new approach calls for custom-designed racks, no-mask anodes, and integrated fixtures. This greatly improves the process, allowing for much faster plating rates, more uniform chrome deposition, and fewer rejects. The tooling is easy to use and, unlike conventional methods, does not require extensive training. The new method provides environmental and health benefits as well: lower pollution footprint, less non-biodegradable waste, and the elimination of handling toxic lead anodes. It's also safer for plating technicians.
The new tooling has all of the components of the plating system in a simple unit. The operator racks the parts, tightens the connections, and then it's just a matter of using a hoist to lower the whole rack into the tank, and the operator has to spend a whole lot less time over the tank.
At both test locations, pilot parts were chosen for their production frequency and complexity of the plating process. Included in the test were the horizontal pin and cover support for the CH-47 Chinook, a variety of pistons, bearing supports, and spur gears from several military helicopters, along with axle and landing gear cranks from F-18 fighters.
The particular part we worked on was the hinge pin. This is a high-strength steel pin. It's very critical to the operations of the aircraft. They're expensive to manufacture, and it's very cost-effective to repair the pin rather than to try to manufacture a new one.
Almost from the day it was launched, the innovative hard chrome tooling project began to realize tangible benefits for these key DoD metal finishing facilities.
One of the main benefits of the tooling is the improved quality of the parts. Not only is the quality of the coating much better, but the machining that has to be done on the coating is much reduced. The plating process can be faster by a factor of 2 or 3. In the bases where this tooling has been installed, the savings in the first year alone have been well in excess of $1 million.
No-mask tooling is now used for more than 80% of all plating operations at Corpus Christi and 36% of plating operations at NAVAIR. In both instances, the estimated cost of implementation was only $200,000, a fraction of the estimated annual cost avoidance. The DoD is currently evaluating opportunities to extend the use of no-mask hard chrome tooling at maintenance and sustainability centers around the world. With massive cost savings and a dramatically reduced turnaround time for parts maintenance, this process has helped sustain the DoD's arsenal and ensure that our aircraft, vehicles, and weapon systems remain in the fight longer.